Hello, welcome back. We are working on chapter 7, rational exponents, radicals and complex numbers. And today we will see section 7.4, adding, subtracting and multiplying radical expressions. The first objective is to add or subtract radical expressions, and let's understand. Rules in the previous sections allowed us to split radicals that had radicands which was a product or a quotient. We cannot split sums or differences. So something that we cannot do, we are not allowed to do is, if you remember, if this is a product, this is something you can do, right? Square root of A times square root of b. This you are allowed to do, but now we are talking about addition, right? And if we are adding, this is not equal to square root of a plus square root of b. So this is something that you cannot do. And the same thing with subtraction, you cannot do this thing as subtraction. So don't think about it. Don't think about it. Like radicals, what we will do to add radicals, we're going to have to identify, we're going to have to find like radicals, which are radicals with the same index and the same radicand. Like radicals can also be combined with addition or subtraction by using the distributive property. So let's check some examples. And we have here, check it out, we have square root of 3 and square root of 3. These are going to be like radicals. And you can actually add, and as you remember, and when you have something like that, it's like having 1 multiplied by square root of 3. So you can add 1 plus 7 times square root of 3, and this is equals to 8 square root of 3. That's how we can simplify this expression that have like radicals. And we have like radicals here as well, square root of 2. And we can add, we can do the operation 10 minus 4 multiplied by square root of 2. This equals 6 square root of 2. And if you check out letter C, now we don't have like radicals because the radicands are different. We have square root of 5, square root of 3, and we cannot simplify. That's it. Cannot simplify. Just keep it like that. Square root of 5 plus square root of 3. And letter D, check out letter D, we have the same radicand, we have 2. But the index is different because this is a square root and this is a cube root. So there's nothing we can do here. We keep it just like that. We cannot simplify this expression. Okay? Moving on. Another example here, simplify the radical expression. And actually we will we will check out here and try to identify like radicals. So square root of 27, we can actually factor this out as 3 times 9, right? 27 is 3 times 9. And, and square root of 75, we can factor out 25 times 3. And we will be able to simplify, to move to outside of the radical. This 9 here, we can move this 9 outside because we can take the square root of 9, it's going to be 3. Let's write down underneath, right here, is 3, square root of 3. And this is a addition. And we can move this out. 25 is 5 squared. we can represent as 5 square root of 3, right? And the result is that we're going to have two like radicals here, square root of 3, square root of 3, and we can combine 3 plus 5, 8, and the result here is going to be 8 square root of 3. Checking out another example, simplify radical expression, this radical expression here. You have 3 times square root of 20 minus 7 times square root of 45. 20. We can rewrite, we can factor out 20, right? Because this is 3 times 20 is square root of 4 times 5. And we can also factor out 45. 45 is 9 times 5. Right? Very good. Now we have a subtraction. We have some factors here that we can simplify. We can remove from the radical, because 4, we can remove the 4 and out here, because 4 is 2 squared. And we can remove this 9 here, because 9 is 3 squared. So let's do this. 3 times 4 is 2 squared, so square root of 4 is 2. Square root of 5, keep the square root of 5, minus 7 times 9, square root of 9 is 3, so we can remove this. 7 times 3, and we keep the square root of 5. Now check it out, we have like radicals. We have square root of 5, square root of 5, so we can combine as like radicals. 3 times 2, 3 times 2 is 6, square root of 5, minus 7 times 3, 21, square root of 5. So this is equal to 6 minus 21, negative 15, square root of 5. Okay? This is the result, the simplification of this radical expression. Another example, and we have another example here. Simplify the radical expression. Negative square root of 75 plus square root of 12 minus 3 square root of 3. Let me get more space here. Let's move this a little bit up. Okay. And starting, we can start factoring out 75. We can rewrite as square root, and 75 is 25 times 3, right? 25 times 3. So plus, and square root of 12, we can rewrite, we can factor out 12. 12 is 4 times 3. And we are also going to have here, and we keep it like that, 3 square root of 3. And check this out. We can actually take this off outside the radical, because 25 is 5 squared, right? We can move it outside the radical. And 4 is 2 squared. So we can also move outside the radical this as square root of 4 equals 2. Let's rewrite them. Negative square root of 25, 5, and we keep the square root of 3, plus 4 is 2 squared, right? Square root of 4 is 2. We keep square root of 3, minus 3, and we keep the square root of 3. Check that we have the like radicals here, square root of 3, square root of 3, and square root of 3. We can combine the like radicals. Combine like radicals, adding the coefficients. So equals negative 5 plus 2, negative 3, negative 3 minus 3, negative 6 square root of 3. Okay, this is the answer, this is the result of the simplification of that expression here. All right, another example. We have another example that we can work out here. Simplify the following radical expression. Assume that variables represent positive real numbers. So now we are working with some variables. We are assuming the variables are positive real numbers. And let's check how to work this out. And we have 3. We can factor out 45, right? 3 square root. 45 is 9 times 5 times x cubed. Oops, x cubed. And actually, instead of x cubed, let's write x. Oops. Let's write x squared times x. So we can simplify. Okay? Plus x square root of 5x. And we can actually take this outside of the radical because the square root of 9 is 3. And we can take this outside of the square root as well, because square root of x squared is x. So let's rewrite. So we have equals. Oops, sorry. Let me adjust this. All right. Negative 3 times square root of 9 is 3. Square root of x squared is x. Square root, and we keep the 5. We keep this 5 here. We keep this x here. Plus, now we have x square root, and we keep this 5x, square root of 5x. Great, and now we have like radicals. Check it out here. This radical have the same index, the same radicand, and this as this one, right? The same index, same radicand. We can combine like radicals by adding the coefficients. And oops, just let me fix this. This is equal to, yeah, this is equal, right. So we combine the coefficients. 3 times 3, 9. 9x plus x. 9x plus x is 10x, right? 9x plus x, 10x. And repeat the like radical, square root of 5x. This is going to be the simplification of that expression here. And one more example. And we have here simplify this radical expression. We don't have variables, we just have numbers. But let's understand how we can simplify. We can factor out 64, because 64 is going to be actually 64 is 4 cubed, right? Plus, and we have a cube root, and 14. We can actually factor out 14, but I think there's no point. We're not going to have anything similar, any like radicals. So let's just keep 14. It's 2 times 7, but I don't see any point. And also we have minus 9. Okay. Cube root of 4 cubed is 4. Minus 9. And we keep the cube root of 14. This is going to be equal to 4 minus 9, negative 5, plus cube root of 14. And I don't see any more simplifications that we can do. This is going to be the final answer. This is going to be the answer for this example here. Another example, a subtraction, and now we have fractions. We have some radicals with a fraction, and actually what we need to do, we're going to do here, is to find the lowest common denominator. Let's try to find the lowest common denominator. Oops. Lowest common denominator between 4 and 3. Let me write down here, lowest common denominator is going to be 4 times 3. Right? 4 times 3 equals 12. And we also will factor out 45, because we might be able to find like radicals to simplify. Let's write this first fraction here using the lowest common denominator 12. If it's 12, we're going to multiply by 3 on the bottom and 3 on the top. So it's 3 times square root of 45, right? Square root of 45. But 45 is 9 times 5, right? Let's write this as 9 times 5. 45 is 9 times 5. The next fraction, minus, we're going to write with the lowest common denominator 12 as well, and we will multiply on the top and on the bottom by 4. So 4 square root of 5. And now we can just use one bar, one line, and long line here with the 12 is a common denominator. And we also can remove, we can get this 9 out of the radical. See? Because 9, the square root of 9 is 3, right? Square root of 9 is 3. So we can write this 3 times square root of 9, 3. And we keep the square root of 5. We keep it here. Minus 4 square root of 5. Those are like radicals, same index, same radicand, so we can combine the coefficients. 3 times 3, 9, 9 minus 4, 5. Keep the square root of 5 over 12, and this is the result, this is the solution for this simplification. Moving on, now we are working on the next objective, is to multiply radical expressions. Let's multiply radical expressions, okay? And let's work with these examples here, multiplying radical expressions. And we have square root of 3 multiplying this, what's inside this parenthesis here. And what we will do right now is apply distributive property. Distributive property, and we're going to multiply square root of 3 by square root of 3, and square root of 3 by square root of 2. Square root of 3 times the square root of 3. I'm going to do this step by step so you don't, you understand. Is the square root of 3 squared, right? Square root of 3 squared minus the square root of 3 times the square root of 2 is the square root of 3 times 2. Remember this property here, we can put together inside the same, the radical of the same index. You can put together these numbers because they have the same index as the square root. And this is equal, the square root of 3 squared is 3, right? And minus square root of 3 times 2 is square root of 6. This is the simplification of that expression. Next one, let me move this up. Next one, we are multiplying now square root of 3 minus 8 by square root of 3 plus 8. And we have to remember this special product here. A minus b multiplied by a plus b equals a squared minus b squared. Do you remember this special product? This is what we're going to apply to find the result for this multiplication. Because here you're going to have a, and this a. Square root of 3 is going to be a, and 8 is going to be b. And the result of this is going to be a squared minus b squared. So it's square root of 3 squared minus 8 squared. Okay? This is square root of 3 squared is 3 minus 8 squared is 8 times 8, 64, right? And finally, the result, negative 3 minus 64, negative 61. Now this is the last example. It's actually a squaring. It's a multiplication, but it's a squaring. You have square root of x plus 1 plus 2 squared. And you have to remember we're going to apply the special products. Remember this one is a plus b, a plus b squared equals a squared plus 2ab plus b squared. Remember this? This is what we're going to apply here. This special product here is what we will apply. So a squared is, and I will do it step by step. X plus 1 squared plus 2 times b, 2 times 2, 4, times a square root of x plus 1 plus b squared, and b squared is 2 squared, 4. Okay, and this is going to be square root of x plus 1 squared is x plus 1, right? Plus 4 times x plus 1 plus 4. Combine like terms. Let me see the like terms that we have here. We have this 4 that we can combine with 1. And that's it. That's it. This is what we can do. So it's going to be x plus 4 times the square root of x plus 1 plus 1 plus 4, 5. This is going to be the final answer of this example, this last example that we have for today. This is the end of our section 7.4. Thank you for watching. See you next time.